So in this video, we'll be discussing about one more type of an interface with respect to the serial communication. So as the name itself specifies that it will be using a single wire. So one wire interface is a asynchronous half duplex communication protocol, and it is developed by Maxim Delas Semiconductor. So asynchronous half duplex communication means asynchronous means again the modules are not working with respect to a single clock. Half duplex means, as we have discussed in the previous video, the example I have given is walkie-talkie. Right, full duplex means whatever the communication that that happens through the telephone. So both the persons can speak at a time, right? Half duplex means the walkie-talkie is an example. After speaking, after one person is completed his speech, then another person can start his talk. That is called as a half duplex. Both the persons cannot talk at the same time. Okay, so that is half duplex communication protocol, and this is developed by the Maxim Delas Semiconductor, and it is also known as a Delas one wire protocol. It makes use of a single wire, and which is also called as a DQ for communication, and follows the master slave communication model. One of the key feature of the one wire bus is that it allows the power to be sent through along with a single wire as well. So whatever the power that is required in order to activate this bus, and that power is also sent to this wire itself, which is called as a DQ. The one wire interface supports a single master and one or more slave. So it again supports only a single master and multi slave. So this diagram will illustrate you how actually the one wire interface looks like. So if you just observe here, so there is a single wire. Okay, that is a single wire which is represented as DQ, and the power to this line is provided directly here. And in order to have a stable current, we are using the resistor which is of 4.7 kilo ohms. And again, the multi slaves are being supported to this, and the port pin being connected to the master towards the left side. So how actually it works? So each and every slave will be having the unique identification number. Okay, each and every slave will be having a unique identification number. For slave 1, it will be having a unique identification number, and for slave 2, again the unique identification number. So like the students will be having the USNs, right? Similarly, the same type, the unique identification number, that is called as an UIN, and the length of the UIN, that is a unique identification number, is 64 bit. So if the master is willing to have the transaction between the slave 2, then the unique identification number is loaded onto this one wire. So therefore this bus is activated only between the master and slave 2. So therefore the transactions happens only between the master and slave. So in case if the master is wishing to have the communication with slave 1, then the unique identification number of slave 1 is loaded into this bus. So therefore this bus is activated only between the master and the slave 1, and the slave 2 cannot send or it cannot receive anything, because this bus is only for the slave 1, because the unique identification number of slave 1 is loaded. Okay, I hope you have understood. The channel has been created only between master and slave 1, because the unique identification number is loaded with respect to the slave 1. Okay, and now we'll just understand what are all the three parts. Okay, the identification number has a three parts. So that 64-bit identification number is divided into the three parts. So the first part is called as a family code, and the second part is called as a serial number, and the third part is called as a CRC code computed from 56 bits. So first part is what? 8-bit, which is called as family code. And what is the second part called as? It is a serial number, and whose serial number length is 48-bit. So what is the first two parts length? 48 plus 8, it is 56. So from the 56, you will be computing a CRC. CRC means cyclic redundancy check. Cyclic redundancy check code is again computed by just considering the first 56 bits. Okay, so these are the three different parts that is there in the unique identification number, and we shall not discuss what is a CRC, what is the serial number, and how the family code will look like. We are just understanding what are the different parts that is there in the identification number. We are not going how to compute this CRC and all.